So here we're going to look at an arithmetic sequence. I'm going to start with the numerical one, and then we're going to come on to the general case, and from this we're going to prove a formula for arithmetic sequences. So u1 is equal to 3 and d is equal to 2 in the first example. So that means u2 is equal to the first term plus 2, the common difference, which is 5. u3 is equal to the second term plus the value of d, which is 2, and we get 7. u4 is equal to the third term, which is 7, plus 2, which is equal to 9, and u5 is equal to the fourth term plus 2, which is equal to 11. And what about un? Well, from what you've seen previously, you probably recognize that this is going up by 2 every time, which means that the general form must be of the form 2n. And how do we get from 2 times 1 to 3? We need to add 1 to find our general term. And that method certainly works for finding the general term for linear or arithmetic sequences. What we're going to do here though is we're going to generalize it into a formula, and the benefit of the formula is that it enables us to solve more complicated problems. So we'll do a similar thing, but this time instead of having u1 being some number and d being some number, they are just u1 and d. So u2 is equal to u1 plus d. No surprises there. u3 is equal to u2 plus d. u4 is u3 plus d, and u5 is u4 plus d, which is exactly what we saw over here. But the problem with this is we can't evaluate it because we don't know the values of u1 and d in these cases. But we can actually do something else here, because in this term here we've got u2, and we know that u2 is equal to u1 plus d. So we can replace it with u1 plus d and then plus d added on at the end here. Similarly, we know that u3 is this whole thing. Well, let's simplify this a bit further. This is u1 plus 2d. So u3 is u1 plus 2d, and then onto that we're adding an extra d. So u4 is actually equal to u1 plus 3d. Similarly, u4 in this formula can be written as u1 plus 3d, and then add on that d. So we get u1 plus 4d. And this gives us a way to see a general formula, because in all of these we have u1 plus some multiple of d. Well, what is the multiple of d? For u2, the multiple is 1. For u3, the multiple is 2. For u4, the multiple is 3. For u5, the multiple is 4. It's always 1 less than n. So for un, we get n minus 1 times d. And this means that for an arithmetic sequence, we know that un is equal to u1 plus n minus 1 multiplied by d. And you are given this formula in the formula booklet. It's a very useful formula that we will use to solve many types of problems involving arithmetic sequences.